Hello dear students, welcome to Unacademy Live. And GATE exam got over and the paper also has been released, and we are very happy with the way in which the questions have been asked, especially analog electronic circuits, right. So as far as my subject is concerned, almost all the questions, not almost all, 100% of the questions, right, you can able to answer, because each and everything has come from whatever I have taught. It may be offline or online or any special class, whatever it is, right, you can go through the things. So I can say very proudly that whatever the efforts we put, they have led to an excellent result. Okay. Now in this section I would like to discuss GATE 2020 electronics paper, in which analog electronic circuits especially I would like to do. Anyway, a few more subjects I will be doing in next coming sections as well. Okay. So let us have a look at the questions asked in analog electronic circuits. This is the very first question. In the circuit shown below, all the components are ideal and the input voltage is sinusoidal. Okay, a sinusoidal voltage is given here. And the magnitude of the steady state output rounded off to 2 decimal places is, right. This is the question. Anyway, we are all well aware of it. It is a voltage doubler circuit. So D1 acts like positive clamper, D2 acts like negative clamper. So what about voltage across the capacitor C2? The capacitor C2 will charge up to 2 Vm, right. The capacitor, actually C1 will charge up to Vm with polarities plus minus, and voltage across D1, if you take it so, it is like, instead of voltage across D1 I can say VO1 otherwise. So VO1 is equal to Vm sin omega t plus Vm. Now look at the capacitor C2, it will charge up to 2 Vm, Vm plus Vm. Directly I am writing the answer because all the analysis we are all well aware of it. So once D2 is on, the current flows in clockwise direction and C2 will charge up to 2 Vm with polarities plus minus. But here the value given is RMS. RMS value of secondary voltage is given. So what they give is Vm by root 2. Vm by root 2 is 230 volts. Then what is your output? It is 2 Vm. So 2 into Vm, it is equal to 2 into Vm by root 2 is 230. So Vm is 230 root 2 volts into 230 into root 2. Root 2 means okay, 1.414. So you will get some 360.44 volts. That is your answer. Okay, you will get the answer around 650.44 volts. Up to 1 decimal I think so. Okay, 2 decimal places. So 260.44 volts. It is as simple as that. Straight away 2 Vm. Just to confuse us, they gave us RMS value, right. So you need to take the peak amplitude. That's the idea here. Very simple question, right. Within seconds you can put the answer. Next one. Look at the second question, right. The components in the circuit shown below are ideal. Means op amp is ideal, that's what they mean to say. If the op amp is in the positive feedback and the input voltage is sine wave of amplitude 1 volt, the output V0 is, what is the output voltage of this circuit? That's the question they are asking. Very, very simple thing. It is in a Schmidt-Trigger circuit, right. We can say non-inverting Schmidt-Trigger circuit. In the Schmidt-Trigger circuit, what is your output? Output is a square wave switching between plus V sat and minus V saturation. So output is a square wave switching between plus V sat and minus V sat. So V sat means you can take VSAT as plus 5 volts and minus VSAT means minus 5 volts. Sorry. It is a square wave switching between plus 5 and minus 5. Okay. Lot of difficult circuits we did. They asked very fundamental circuit, right? Just like that, while reading the question itself, you can put the answer. Option A is correct. A square wave of 5 volts amplitude. So here, what is the amplitude of this square wave? 5 volts. Peak to peak means 10. That's it, right? Already we are aware of the analysis of this circuit. Just they ask to find the output. Next question. Very fundamental question. Of course, first time they gave analog this much easy. I haven't ever seen analog paper being given this much easy, right? But if they should give tough, to be frank. If they give tough, then only the real stuff comes out. Easy means everybody can able to write it. Anyway, right? It has even with that, some people told they did mistakes, right? Which we are not supposed to do. Some simple paper means definitely you can expect some tough competition only this time. Okay, and coming to this question, in the circuit shown below, all the components are ideal. Okay, op amp is ideal. If V input is 2 volts, input is given as 2 volts. The current I0 sourced by the op amp is, what is the current coming out of op amp? This is what they are asking. Okay, how to find that current? Very simple and fundamental question it is. So let me take this is V output. So what can we, due to virtual short, it is 2 volts we can take. And what is the output of this circuit? What is V output? 1 plus Rf by R1 into Vi. So V output is equal to 1 plus Rf means it is 1 kilo ohm by R1 1 kilo ohm into 2 volts. So it is equal to 4 volts. We can write. Next point. See, we have got output is equal to 4 volts. Then they are asking us to find I0. So how to write I0 means, let us take this node equation. Let me take this is node A. If I take this node equation, node A, then V output minus 2 by 1 kilo ohm plus V output minus 0 by 1 kilo ohm minus I0 is equal to 0. I0 they are asking, anyway I0 is entering. I took V output minus 2 by 1k, that is the leaving current. V output minus 0 by 1k, leaving current. I0, I0 is entering. So if I take node A, then V output minus 2 by 1 kilo ohm plus V output by 1k, sorry, minus I0 is equal to 0. We can write it. What is V output? It is 4. So 4 minus 2 by 1k by 1 into 10 power minus 3 plus 4 by 1 into 10 power minus 3 is equal to I0. So what is your I0? It is equal to 6 milliampere. That's it. Okay. So right, if you see this kind of questions, right, we really will be disappointed, because such a simple question they have asked. We expect lot of things. We studied, we did a lot of analysis, much complex circuits we analyzed, and unfortunately this time they gave a simple question on this op amp circuit. Okay, like this we can do the problem. Next question. It is a voltage regulator. So in the voltage regulator shown below, V input is unregulated at 15 volts, V input is 15 volts. Assume that VBE is 0.7 volts and the base current is negligible for both transistors or both BJTs, both Q1 and Q2, whatever you take. Then if the regulated output is 9 volts, if the regulated output is 9 volts, the value of R2, what is the value of R2 they are asking. Okay, they are asking us to find the value of R2, neglecting the base current. Okay, so base currents are neglected, means we can neglect this current if I assume Q1 and this one as Q2. Okay, this IB is neglected and this IB is also neglected, neglecting the base currents, right? It is not 0, right? We are neglecting it, means its value may be very small to be neglected. That's the concern. I'm just neglecting the value of IB. And they mentioned VBE is equal to 0.7. So VBE is 0.7. So this VBE, base to emitter voltage, it is 0.7. This is also 0.7. Okay. Right. Once you neglect IB, then I can write this voltage as base voltage. VB, it is just nothing but VBE plus VZ. VZ has polarities like this. So I can write here VB, it is equal to VBE plus VZ. I can write. It is VBE is given as 0.7 volts and it is 3.3. 0.7 plus 3.3, it is equal to 4 volts. VB we have got it to be 4 volts. Okay. And the next point, VB can also be written like sorry, V output by R1 plus R2 into R2. So how to write the relation between V output and VB? Because IB is neglected, so from V output whatever the current comes, entire current has to go like this only. If I say this current is I, this is also I, you can take it because IB is neglected. So what is VB? Also VB is given by also VB is equal to V output by R1 plus R2 multiplied with R2. I can write it. Voltage division rule. Okay. Then in which VB is known, V output is known, R1 is known, unknown is R2. So find the value of R2. Such a simple question they have asked. So it is VB is equal to so 4 is equal to 9 into R2 by R1 is 1 kilo ohm plus R2. So if you solve for R2, you will get it to be around 800 ohms. They are asking us to find the value of R2 in ohms only. Its answer is 800 ohms. Like this, we can do it. There is nothing, right? So you need not apply more intelligence for doing this kind of questions. Okay, right. Next one, active filters question. See this, the components of the circuit given below are ideal if R is equal to R is equal to 2K and capacitor is equal to 1 microfarad. Then the 3 dB cutoff frequency of the circuit in hertz is, what is the 3 dB cutoff frequency of this circuit? It is a first order low pass filter. So many times I have gone through, I discussed this one, and most of the times they are asking this question only. Okay, so if you look at this question, due to virtual short it is 0 volts. So here it is 0, it is 0, there is no role of this 2R, and here it is 0, it is 0, there is no role of this 2C. Means this circuit can be further redrawn like this. it is just nothing but a low pass filter circuit. Okay, so if you look at this low pass filter circuit, what is its transfer function? We all are well aware of it, right? It is like A by 1 plus S tau. I am directly writing it. To be frank, okay, minus Z2 by Z1 and all, we are well aware of it. And what is its cutoff frequency? The cutoff frequency is given by this RC combination, and the gain is given by R2 by R1 like this. Here R2 is equal to R1, we can take like this. So if you take the cutoff frequency, straight away I am writing 1 by 2 pi tau, where tau is equal to 1 by 2 pi RC. Okay, H of S, right? It is just, I have not written it, not required, minus Z2 by Z1. Very standard circuit, almost some 6th or 7th time they have given this circuit. Okay, so H of S is equal to A by 1 plus S tau, and of course it is V output by Vi is equal to minus Z2 by Z1. If you substitute Z2 and Z1, what we get is this, right? In this example, A is 1 and we can see it so. So if you substitute those values, 1 by 2 pi into R is given as 2 kilo ohm and C is equal to 1 microfarad. So if you substitute those values, how much do we get? 1000 by 4 pi, or 1000 by 4 pi means 250 by pi. So 10 cancel, 25 threes. So you will get it around 79.58. Option D is correct, right? Just approximately I wrote it. Anyway, you will be getting the answer to be around 79.58 heads, I can say. Okay, like this. You can see how simple the question is, right? So many very standard circuit. Just to confuse us, they gave this 2R to C. But once you apply virtual short, it is 0. These two impedances do not play any role. We can take it so. Next one. Amplifier circuit, a very standard and very regular question it is. Okay, so for the BJT in the amplifier shown below, VBE is equal to 0.7 volts and KT by Q, thermal equivalent voltage, thermal voltage, it is 26 millivolts, and assume that BJT right, assume that BJT output resistance RO is very high and the base current is negligible, IB is negligible, and the capacitors are assumed to be short circuited at signal frequencies. The input voltage is directly coupled. Okay, doesn't matter. The low frequency voltage gain V output by Vi of the amplifier is. What is the gain of the amplifier circuit, they are asking. Always, right? So how many times we did this kind of problems, right? Once we start amplifiers, this is a very basic circuit, right? We deal with, of course. So as far as the circuit is concerned, first let us have a look at its DC equivalent circuit. With respect to DC, what do we get? All the capacitors act as open circuit and the AC source is removed, but it is not superposition, right? So if I take with respect to DC, with respect to DC, what do we get? It is connected to ground. Like this. Here it is 10 volts and here it is minus 10 volts, 20K. Okay, it is 10 kilo ohm, let it be. So always we are well aware of it. So we neglect here IB. IB is neglected, and hence we can take IC is equal to IE. It is IE. IE is equal to IC. So how to find its value? VBE. If I take this loop equation, from this loop equation I can write directly IC or IE. So what we can write? It is VBE plus IC into 20K minus 10 is equal to 0. So IC or IE, I can write even IE also, or IC is equal to, IE is equal to 10 minus 0.7 by 20 kilo ohm. So how much do we get? 9.3 by 20. So 0.465 milliampere. We can take like this. 0.93 by 2. 93 by 2 means 0.465 milliampere. Okay, from the DC equivalent circuit, first we calculate what is IC. Okay, fine. Once IC is done, next you need to see GM value. What is GM? GM is equal to IC by VT. IC is 0.465 milliampere by VT is 26 millivolts. Okay, let it be. Its value is found to be 0.465 by 26. Leave it. Mos. Its units are mos. You will get it around some 17.88 millimos like this. 17.88 millimos. Okay. If you want, you can write it. Otherwise, also we can leave it so that we can save the time. Right? However you do, doesn't matter. Now, with respect to AC. So, first we need to find GM. Next, let us take with respect to AC. Small signal AC, if I take with respect to small signal AC, what we can write? See this circuit. With respect to AC means with respect to this signal, DC source should be 0. It should be connected to ground and it should also be connected to ground. Both the capacitors act as short circuit. We can take it so. So, with respect to AC, right? It is connected to ground. It is RC. V input, and once this capacitor is a short circuit, RE parallel is short circuit, so it is short circuit only. Next, once this capacitor acts as short circuit, RL appears. So here it is short circuit, and from this point I can write RL. It is 10 kilo ohm, and RC it is also 10K. V output. Like this. You can imagine the very basic circuit only, right? There is nothing special and no difficulty in it at all. Such a simple question they have given. So, right, if you take the gain of this circuit, what is the gain of the circuit then? Gain AV is equal to V output by VI. It is equal to minus GM into capital RO, where capital RO is RC parallel with RL. Anyway, small RO is given as very large. So, capital RO is equal to RC parallel with RL. So, here it is equal to R, I can write minus GM into RC parallel with RL, I can write. So, what is the GM value? 0.465 by 26 into RC is a 10 kilo ohm, RL is 10 kilo ohm, 10K parallel with the 10K, it is 5 kilo ohm. So, it is 5000, and if you solve it, how much do you get? Of course, negative sign is a must. Directly I am writing here 5000 because it is like 10K parallel with 10K as I mentioned. Its value is 5K. We can take it. So, if you solve it, you will get the answer around minus 79 point something, yes, minus 89.42, I think so, minus 89.42. Option B is correct here. Option B is correct. Minus 89.42. Because it comes around 17.88 millimos, 17.88 to 17.85, approximately you will get 89 exactly. This is your answer. Okay. So you can imagine, you never write, no question has been given tough as far as this paper is concerned. And if you observe my class notes, right, it may be offline or online or a recent special classes, everything you can observe, right, just like that you can write the questions. Really, there is no point of spending time. While reading the question itself, you can able to put the answer. It is not like I have to think of it, what comes, what is going to happen and all. Such questions are not there. Right, this year it is a luck, but we can't expect every time like this. We will do our best in all possible ways, but next year we should be very careful, as this year it has come this much easy. Definitely next year they may trouble us. If we take the things easy, definitely they will put us in trouble. So we should be more alert. If they give okay easy, we don't expect the paper to be easy. That's what I can say. First of all, at least okay, this question, right, may take a bit time. All the questions so far what have been done can be done within less than 1 minute. That's all. Within seconds you can put the answers. As I'm explaining, discussing with you guys, right, with you people, I'm writing all those things, but really no question takes more than even 1 minute. Okay, and this one, anyway, we know all the procedures, how to do all these questions. Okay, so coming to this one, right, using the incremental low frequency small signal model of MOSFET device, the normal equivalent resistance of the following circuit is. What is the resistance looking into the source terminal of MOSFET? This is the question they are asking. Okay, here they give GM and RD. GM and RD are given. What is the resistance looking into the source? Right, even with respect to this, related to this also, we did lot of questions, right, lot of exercise. Whoever has attended my sessions, right, they never feel like these questions are tough, and you never feel like you need to think of it before starting the question. Just like that, while reading the question itself with a very happy and smiling face, just like that you will be able to write it. Right, the people who had already attended my sessions I'm speaking, of course these are all not really tough, anybody can answer, I personally feel, because these are the minimum things we deal while taking the subject, right, lot of extra, right, so many things we discussed, but this time the paper is really a bit easy as far as analog part is concerned. I may say, like, as everything has come within whatever has been discussed, it that's why it is easy, but relatively also I can say easy only, I cannot say tough. I think 2018 paper was a bit time taking and tough, even that is also not so, some people felt recent means compared to that it is not a tough paper. Okay, so how to do this question? Say this, I think this is the last question in this year, right, just right. See, these many questions and all are very simple also. So how to find the resistance? While finding the equivalent resistance, looking from the source, we have to take the DC sources 0. So what is the procedure we adopt? Here I am connecting a dummy source Vx, current coming out of it is Ix. So here the resistance or Norton's resistance they asked, right, the Norton's equivalent resistance, what you can write for that? Rn is equal to the voltage by the current that is leaving the source. We can write, okay, let me take the polarities like this. Always we take them with respect to AC only, we never take them with respect to DC. This is what we can see. Right, next GM and RD are given. Okay, fine. Then let us take replace the MOSFET by means of its AC equivalent circuit. What do we get? So with respect to AC, what do we get? Just see this. Further, I can take the circuit like this. We know it is gate to source voltage and it is GM into VGS, and in parallel with RDS. We write small rd or small rds or RO, whatever you take, all mean the same. We can write this is a symbol of, okay, sorry, instead of symbol I am writing it's a small signal equivalent circuit. Next what we have is RD, drain resistance RD, capital RD I can write, which is going to ground, or R, instead of RD they give R. Some resistance R is given, you see here. R from the drain, R is going to ground. Ground means instead of showing at the top I am bringing it to bottom. Next from source Vx, I can say gate is anyway connected to ground. So what we can take is from this it is Vx and this current is Ix. I can write it, and the gate is also going to ground. Gate is also going to ground, like this, plus minus I am taking like this. Now always the current entering the drain is ID, I can say, and here let me write this resistor here RDS. So this current is GM into VGS. What about this current? ID minus GM into VGS. So I can write this current as ID minus GM into VGS. We can write. And again these two currents join together, and this current is just nothing but the downward current is ID. So I can take the downward current as ID. Whatever the current that flows through drain, the same thing will flow through source and drain terminal. So which means ID is equal to minus Ix. So for Ix is assumed upwards, ID is coming downwards. So definitely I can write ID is equal to minus Ix. The first point we can take it. Ix is going upwards and ID is coming downwards. Okay, fine. Now we need to derive what is Vx by Ix. Okay. Next, one more thing, Vx means voltage at this point with respect to ground. And what about VGS? Or if you see, Vx means one end of Vx is here and other end is connected to ground. Ground means that is connected to gate only. Gate and ground are same and source is here. So from this what you can write is, or if you take this loop equation also, we can write VGS plus Vx is equal to 0, that is Vx is equal to minus VGS. So I can write Vx is equal to, or I can write VGS plus Vx is equal to 0 implies Vx is equal to minus VGS. Vx is equal to minus VGS. This is what you can see the relation between VGS, Vx, Ix and ID. Okay, then here I am taking this loop equation. I am just looking at this loop equation. If I take this loop equation, what we can write it? Simply speaking, if I take the loop equation, here the voltage drop here R across R is, this current is ID, ID into R plus voltage drop across this RDS or across this current source, that is RDS into ID minus GM into VGS plus Vx is equal to 0. We can write so. 3 voltages in this loop. So if I take the loop equation, or you want you can write it as loop 1. Just for your information sake only I am writing it so. So loop 1 implies ID into R plus ID minus GM into VGS. Okay, here the place doesn't permit, sorry, I will write it in the next place. Right, if I take the loop equation, loop 1 implies I can write ID into R plus ID minus GM into VGS into small rds plus Vx is equal to 0. I can write it. Let us write ID terms first. ID into capital R plus RDS minus GM into VGS into RDS plus Vx is equal to 0. I can write. And instead of ID, I can write minus Ix. So ID and minus Ix, I can write it. It is capital R plus RDS, and GM into, instead of minus VGS, I can write plus Vx. So it is GM into RDS into Vx, I can write it, plus Vx is equal to 0. I can write so. So that further I can write it like Vx into 1 plus GM into RDS is equal to Ix into capital R plus RDS. And the resistance, Norton's equivalent resistance, is Vx by Ix. It is equal to R plus RDS by 1 plus GM into RDS. That's it. That is your final answer. Just what is correct? If you look at the options, right, it is like small rds plus R by 1 plus GM into RDS. So option 2 is correct here. This is what you can see. And if you observe the solutions, I am feeling like I have done a very simple questions in my class, right? Even I have not changed the notations also, as it is my class notes. If you observe, so the same, whatever the approaches, right, I have taught in the class, as it is you can see here. And it is not like just for the sake of examination I have brought something new and explaining it. You can see my class notes, and whoever have attended my offline classes, online classes or special classes, they will clearly understand just what I did in class, the same terminologies, the same approaches, not even a single step I changed. You can understand from this. Okay. So anyway, I should in advance congratulating all the students who have written well, right? I hope everyone should write well, right? These are the things I can discuss about analog paper as far as the present year is concerned, to 2020. And tomorrow I will be coming with one more new topic related to the GATE paper. I will be solving, as I have been teaching for last 6 months. I did more things on analog, that's why I am doing it so. And let us see the remaining papers also, right? I will be discussing. And of course today I am discussing only the electronics paper. Tomorrow electrical and instrumentation papers both together I will be discussing, right? We will see that as well. Okay. And coming to anyway, Excel 2021 has already started. Excel GATE 2021 has been already started. 10th we started the sessions. I already took 2 sessions, right? Due to some health issue, I could not able to take yesterday class. No issues, of course. Some other program was also there, right? As I was out of station, I could not able to come before you guys, even though the paper was released yesterday. Okay, doesn't matter, right? I will do all the papers, questions from the subjects I have been handling tomorrow onwards. Today I did something, and in next section some other subject I will be doing. First I will complete analog, of course. And you can see the solutions I did, and you can compare the notes. You don't find any difficulty, and we did lot of wonderful exercise in the class compared to what has been asked here. Okay, you can see the approach, and it is like what I do in the class, the same thing I did here. Not even one step additionally I spoke here. Okay, that's what. Anyway, next year you don't expect the things to be that much easy. We don't want the paper to be easy. First of all, if it is easy, everybody, an average student or have the person who is having average preparation can also be able to write it. If the paper is very much tough, then the people whoever is having the real stuff will come out, right? That's the best way of expecting the question paper. It should be very tough. Let us test our knowledge, and whatever the efforts we put, they should lead to the fruitful result, right? It should not be like some average student is also getting good score. Such things should not happen. Okay. Anyway, it is most of the students, it may be luck. Some students, they may be this way or that way a bit disappointed. Doesn't matter, but all other subjects are also there. It is not like only one subject. With respect to other subjects also as a whole, right, we have to salute GATE paper, no doubt about it. So, and Excel, coming to Excel GATE 2021, as I told, classes have been already started. Myself and Suresh sir, right, you may be going through the sessions, right. We started with networks and EDC parallelly, right. Things are going on, and the next point is, right, and from 17th onwards, Excel GATE 2021 for electrical engineering will be starting, and we are launching one more senior-most faculty in India. The most famous educator. I don't want to mention the name, his name. Some suspense we want to maintain it, and maybe today or tomorrow, right, he will come online and he will talk to you people regarding the GATE paper or the strategies, whatever the things have been asked and all, and so that the team is becoming more and more strong. Of course we have, but we want to launch them from their side itself instead of myself mentioning the name, right? And you please try to take the subscriptions as early as possible. If you delay it, the later on, right, even if first 2-3 classes, anyway we go a bit slow to see that the students are should not be in trouble, because if we keep on starting the things and doing it fast, right, later on you will be joining live and you will be attending my section, not only my section, any educator session, right, and some prerequisites might be done earlier, so you need to revise those already the classes which have been done and this present class, and understanding is this present topic may be a bit difficult because you are not aware of the classes which have been already done, so you need to balance both. That is why try to take the subscription as early as possible, so that you will enjoy from tip to toe in all the subjects, and we will be revising them in different strategies, keeping second, third year students in mind, keeping final years in mind, and passed out students in mind. Different levels of teaching, different levels of sections we are planning. Okay, try to make use of the resources available at your doorstep at very less price. Right, and we are all here with you guys or with you people, and try to make use of the best resources available from Unacademy Live GATE. Okay, and thank you all. See you again with some other new topic tomorrow. New topic in the sense maybe networks or signals and systems or controls I will be doing tomorrow. Right, thank you all. See you.